Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at polyatomic ions. Well, in the other lesson, we learned about monoatomic ions, which we use the periodic table to determine the chemical formula as well as the charges of each monoatomic ions in a specific group on the periodic table. The prefix mono is one, but the prefix poly is many. In this case, polyatomic ions consist of two or more atoms. That's why we have the word atoms right there, that are bonded together, but they function as a single ions. Now let's look at this example right here. We have, this is a hydronium ion. If I write this out like this, it would be H3O plus. And again, this function together as a single unit. And that's why we use this bracket right here. Notice how we have the charge right there. So this bracket is enclosing everything in this polyatomic ions. Here we have hydroxide, which is OH minus. And again, we have the bracket that encloses everything, and the charge represents the entire charge of this particular polyatomic ions. We use the term net charge. Here we have a more complicated polyatomic ions, and that is acetate. Acetate is C2H3O2 minus, or it could be written as C3H2OO minus. Now don't get tricked, okay? Sometimes it could be written like this, or sometimes it could be written like this. But you can see that this whole entire molecule in here functions as a polyatomic ions. Now the challenge for this lesson is that when we look at a chemical formula, can we determine the composition in terms of ions that make up that particular chemical formula? For example, right here, we enter the chemical formula of the cation, which is the T right there, that's positive, and anion, which is negative ions, okay, make up calcium carbonate. Can we look at the chemical formula and distinguish and determine what is the cations, what's the anions that make up this compound? Well, we know that the cation is always written first in the chemical formula as well as the name. So right here we see calcium right there, right? We know right away calcium is coming from the periodic table. So we have Ca, because we cannot really enter the superscript, so we have to use the caret symbol Ca 2 plus. And how do I know it's 2 plus? Well, I have to go back to my periodic table. So this is in group 2A, remember that, okay? See how we combine the other lesson to this one? And then carbonate, CO3, let's go over here, find carbonate. This is right there, CO3 2 minus. So therefore, we have CO3 and caret 2 minus. And we look at this carefully, right? Look at this 2 minus. So therefore, this must be 2 positive as well, because they need to cancel out. Now let's try another one. So in this case, we have this K2CO3. This is potassium carbonate. And we know potassium is in what group? Well, potassium is in group 1A, so it has 1 plus right there. Okay? And we have carbonate, again, CO3, caret 2 minus. And we look carefully right there. Look at this. Carbonate is 2 minus right here, right? So we have 2 minus. How many potassium do we need to cancel it out? Well, it showed us that we have 2 right there. So we have K plus and another K plus. What's the total? That is equal to 2 plus. It cancels each other out with that one. Okay? You see how that works? Now let's go down to the next one. We have water. Look at water. Well, water is not really an ionic compound, but we look at water, it's sometimes written as like this. Water is a composition of OH minus and H plus, okay, right there. So we have H plus. Now, water is pretty much a very unique molecules that we really need in our daily life, but it's so essential, it's so abundant that we have to understand, even though this is not really about ionic compound, but we can see that there are positive charge and negative charge. The composition of water is important. I know this is not completely like negative, completely positive, but it's actually, when we look at a compound, it is a covalent compound, okay? This is when it comes to sharing electron. I want to show you this because water is so common that we need to able to look at water molecule and split into this. Because when we work with water molecule, it's often break into positive charges and negative charges, ions, okay? So keep that in mind. That is an exception. It's not an ionic compound. It is a covalent compound that can be easily split into the positive component, which is H plus and OH minus. So every time you see water, you're just able to recognize in this form. Let's try another one. Enter the chem formula. In this case, we have ammonium hydroxide. Well, I gave you the name. That's pretty easy. But we know that there's no such monoatomic like this. We know this right here. We know this part, but we don't know this part. So this hydroxide right there, OH with the caret minus, okay? But what about NH4? NH4 is ammonium, which is one of the two most important positively charged polyatomic ions. The other one is H3O plus, which we just looked already, okay? So in this case is NH4 plus. There you go, with the caret symbol, of course. So in this case, we have NH4 with the caret symbol plus right there. Let's try the last one. We have sodium. We know right away that sodium is Na plus, because that's in group 1A, and acetate right there. We have C2H3O2 caret minus. And that is how we look at a chemical formula and try to understand it in terms of polyatomic ions and apply what we already know about monoatomic ions to understand the composition of a compound and how we have ions combined together to make a stable molecules or compound that exists in our daily life. And as always, if you have any question about the practice or about this video, put in the forum, and we'll see you next time on another exciting chemistry lesson.